Hello, welcome to Business 311 Finance. My name is Dr. James Yohe, and I am the instructor for this class at Huntington College. Today, we're going to work on what's called the free cash flow valuation model. Free cash flow valuation model. Okay, and oops, that's the wrong side. There we go. Okay, um, to briefly introduce the model, the free cash flow valuation model is an alternative to the dividend valuation model presented earlier in the chapter. A firm's value can be estimated by using its projected free cash flows. This approach is appealing when one is valuing firms that have no dividends, so they're retaining all of their earnings. History or startups, or when one is valuing an operating unit or division of a larger public company. Although dividend valuation models are widely used and accepted in these situations, it is preferable to use a more general free cash flow valuation model. So we're looking at firms that don't have dividend history, startups, okay, or if we're looking at an operating unit or division of a larger public company, okay, maybe we're buying that division, okay. Now, the free cash flow valuation model is based on the same basic premise as dividend valuation models. The value of a share of common stock is the present value of all future cash flows. It is expected to provide over an infinite time horizon. Okay, once again, we're making assumptions about the future. Okay. However, in the free cash flow valuation model, instead of valuing the firm's expected dividends, we value the firm's expected free cash flows. And these are defined in Chapter 4. We don't calculate them here, we take them as given. They represent the amount of cash flow available to investors, the providers of debt, and equity owners after all other obligations have been met. The free cash flow valuation model estimates the value of the entire company by finding the present value of its expected free cash flows discounted at its weighted average cost of capital. Okay, that is this RA here. That is your weighted average cost of capital. It is expected average future cost. It is the expected, which is the expected average future cost of funds. And again, this is done in Chapter 9, so we're going to take this as a given. It's going to be given to us in these problems. Okay. Now, here we have the value of the entire company, and we have these future cash flows out to infinity, and we are discounting them instead of using, as we did before when we were using dividend valuation models, instead of discounting it by the required return on common stock, here we're discounting it by the weighted average cost of capital. Okay. Now, because the value of the entire company is the market value of the entire enterprise, that is all of its assets, to find common stock value, VS, we must subtract the market value of all the firm's debt, and that is VD. So we do this calculation up here for VC, then we subtract the value of the company's debt and the market value of all preferred stock, VP. And this gives us VS, okay, which is the value of the common stock. Now, because it is difficult to forecast a firm's free cash flow, specific annual cash flows are typically forecast for only about 5 years, beyond which a constant growth rate is assumed. Remember, in order to value a company, we have to make assumptions based on our judgment or research about future cash flows in this case. Okay? So in these models, we're typically going to have 5 free cash flows, which we have used some method to predict. And then we're going to use something very similar to a growth model to go from year 6 on to infinity. That will give us a present value in year 5 of all those future cash flows, and we'll add it to the discounted value of the 5 cash flows that you are given in these problems that we have predicted. Now here, we're going to go through an example from the book. So here I've got 5 years worth of free cash flow predicted for this firm, okay? And then we're given a expected growth rate of future cash flows after 2020, right? That's after the 5 years, of 3%. The weighted average cost of capital is 9%. The market value of all debt is given to us here, and that is $3.1 million. And the market value of all of our preferred stock is $800,000. And then later on, we'll be using these number of number of shares of common stock outstanding, which you have 300, to value each share of the stock. So the first step when we do one of these models is we have to calculate the present value of the free cash flows occurring from the end of 2021 to infinity, measured at the beginning of 2021. Okay, and that is at the end of year 2020, which is our 5th year here. Because a constant rate of growth in free cash flows is forecast beyond 2020, we can use the constant growth dividend valuation model to calculate the value of those free cash flows. So this is very similar to the problem that we did last video when we looked at the variable growth model. We're going to calculate the present value of these 5 cash flows. So we're doing this in 15, my fault. And we're expecting these cash flows in the next year, 16, the year after that, 17, 18, etc. Then, once we get here, we're going to say, all right, once we get to this point, we can't do a good job of predicting free cash flows, so we're going to make an assumption about the rate at which they will grow, and we'll calculate a value for the 2021 free cash flow, as you see here, just like we did in the last model for n plus 1, the dividend at n plus 1, and we'll start doing our models. So here they do it backward. Instead of calculating the present value of each one of these free cash flows, we start off in 2020 by calculating the present value of the future cash flows from 2021 on into infinity. So the first thing we have to do is calculate the free cash flow for 2021. Here, we take the free cash flow from the year prior, the $600,000 that we made in free cash flows in 2020, and we multiply it by 1 plus the growth rate. That will tell us how much we'll have in free cash flows in the next year, or how much we're estimating them to be. RA is our weighted average cost of capital. That's what we're discounting it by, minus the growth rate in the free cash flow. So we took the 600,000, multiplied it by 1 plus 0.03. That goes in the numerator. And then in the denominator, we took the 9% weighted average cost of capital and subtracted out the predicted 3% growth rate in free cash flows. So this gives us $618,000. That is the free cash flows in the year 2021. And we divide it by 0.06 or 6%. And that gives us a value in 2021 of those cash flows at $10,300,000. Now, that is the value in the year 2021, but we're in 2015. So the next step we will need to do is we will need to calculate the present value of those free cash flows. Now, one thing to remember here is that this value is the value of those free cash flows in the year 2020. Okay? We're going to add that to the free cash flow from 2020. And what we're really going to be discounting later is $10,900,000. The present value of the cash flows from 2021 on into infinity, calculated for the year 2020. We just did that growth model for the value of these things in 2020. And we're going to add them to the actual free cash flows in 2020. And then we'll discount that to the present later. Step 3, find the sum of the present values of the future cash flows for 2016 to 2000 through 2020. So here we had $400,000 in free cash flows next year. We have to discount that by 1 plus the weighted average cost of capital, which is 1.09. So we're going to take, there's a number of ways you could do this. The easiest way would be to enter this free cash flow, $400,000, as a future value in your BA2 plus calculator. Then we would enter a 9% interest rate for the IY button. We're starting from 2015. This cash flow is 1 year away. So we're going to take 1, and that's going to equal our n. Then you could compute the present value. Or you could take the free cash flow, just divide it by 1.09, in this case to the first value, and get the same answer of $366,972. Now here, I've got the free cash flow for the year 2017. I took 1 plus my weighted average cost of capital, added those two together, 1.09, and then I squared it. And I get 1.188. So I could do two things. I could take $450,000, divide it by 1.188, and that would give me $378,788. Or I could enter $450,000 as a future value, 9% IY, 2 years as my N, or number of periods, and then hit compute present value, and I'll get this same number. So we keep doing this for all of the first 4 years. The 5th year is different. Here, we're taking the 5th year free cash flow and adding it to the 5th year present value of all the rest of the cash flows from year 6 to infinity. And all we do here is we take the present value, we're going to calculate the present value of this $10,900,000 in free cash flows plus the present value of additional cash flows in the year 2020. Divide it by 1.09 to the fifth power, and we'll get $7,082,521. We could do it that way, or we could enter, after we cleared our mind, cleared our calculator, and cleared our TVM, $10,900,000 as a future value. We could enter 9%, our weighted average cost of capital for our IY. This is 5 years out, so we'll enter 5 as N and then compute the present value. Once we've completed all these present values, we add them together, and that becomes VC, the value of the entire company. Now, that is just the value of the assets, the thing that the firm owns. We still have to subtract out the value of its debt, and that was given as $3,100,000. So if we go back, you can see I carry this number forward onto the next page. That becomes the value of my company, VC. I subtract out VD, okay, which sounds like something you don't want to catch. And then I subtract out the value of the preferred stock, VP. That was given to us on the prior page in this other data section. You can see those here. So once we subtract out the value of the debt, the value of the preferred stock from the value of the company's assets, we get a common share value of $4,726,426. I'm sorry. Let me read that again. $4,726,426. Now it looks like we're done, but we're not. One of the other things we want to know is what is the value of each common stock share. To get that, we take the value of all the common stock, $4,726,426, and we divide it by the 300,000 shares of common stock. When we do that, we get a common stock valuation of $15.75 per share. I hope this helps you. The key thing to doing this is to remembering the steps. Now, this is basically the same thing we did for the variable growth model. The only difference, if we go back, is we're using free cash flows instead of dividends here. We're using the weight-adjusted cost of capital here instead of the required return on common stock. And then we're subtracting the growth rate of the free capital, of the cash flow, free cash flow. We're subtracting that growth rate from the weighted adjusted cost of capital. There's really no difference. They skipped or they combined a step here when they added the year 5 free cash flow to the present value of the rest of the free cash flows from year 6 to infinity, calculated as a present value in year 5. So they combined those steps to get this number down here. That to some degree makes the calculation a little easier. Once we've calculated the present value of all the individual free cash flows year 1 through 4, then calculated the present value of the 5th year's free cash flow, the $600,000, plus the present value of the year 5 valuation of the rest of the cash flows, we can add that up and get the value of the company. It becomes a little bit different because when we did that with dividends, we were pretty much done. But we have this additional fourth step here where we have to subtract out the value of the debt and the value of the preferred stock from the value of the company and its assets. That gives us the value of common stock VS. Then we take VS, divide it by the number of shares, and we can get an estimate of the cost or a value for each share. Thank you very much. Have a great day. I hope this helps. Goodbye.